Hello, I'm excited to describe my research journey, making progress in the problems of perception, image generation, and forensics. We begin by asking, what makes an image look good to you and me? Can we understand this process enough to build a computational model of human perception? Next, can we leverage such models to build AI tools to generate perceptually pleasing imagery? By doing so, we aim to allow everybody to express themselves visually and tell their own stories. Finally, a growing concern is the proliferation of fake malicious imagery, fooling human perception and spreading fake news. As such, can we build methods to reliably detect fake imagery even with new generation methods coming out daily? We'll start with the task of understanding human perception. To begin, let me ask you a simple question. Which patch is more similar to the one in the middle, the left or the right? While you and all humans I've tested choose the one on the right, traditional metrics like L2 and SSIM, which actually won a technical Emmy award, choose the one on the left. While seemingly trivial, creating a computational metric that is consistent with humans has deep implications: graphics, vision, image processing, and neuroscience. We were able to make headway on this problem by collecting 500,000 psychophysical judgments, similar to the example here, and turning our LPIPS metric, which is much more predictive of human behavior. This has led to widespread adoption. It's an industry standard. For example, in the past 5 years, GANs and diffusion models have revolutionized image creation. Notably, these two works, StyleGAN and Stable Diffusion, were created by NVIDIA and Stability AI. But looking behind the curtain, they make use of our method. Because these methods aim to produce perceptually pleasing results, LPIPS is a ubiquitously used building block for doing so. It applies across a broad spectrum of tasks as well, anytime an image needs to be evaluated. Now, since the time I was in grad school, I myself have pushed on generative modeling with the aim of making content creation more accessible for everyday people. Let me share a few highlights. Back in 2016, I developed AI-based colorization methods. To my knowledge, this is the first generative application to actually make its way into broad use, as we deployed it later in Photoshop Elements and Adobe Photoshop. I take delight knowing amateur users can quickly colorize their family photos, as I enjoy doing so. Furthermore, we developed a method for data-driven image editing called swapping autoencoders. This method was published in Europe, but also made real-world impact. It was deployed as Landscape Mixer, allowing users to seamlessly edit their outdoor photos. Finally, I helped develop a super resolution feature in Adobe Lightroom, which was recognized by Time magazine as a top invention. These projects successfully used insights and advancements in perceptual understanding to help democratize image synthesis, empowering everyday users to create content in ways that they could not do beforehand. Equally important, due to the proliferation of generative technologies, is being able to identify whether images are synthesized. One shouldn't have to be a major research lab or the CIA to do this. We aim to use AI to democratize image forensics for the broader public. One common method for making fake images is good old Photoshop, so we started by developing a tool to detect it, which I'm presenting here at an Adobe event. Here, I'm showing that we can warp an image with Photoshop, and our tool can identify and even reverse the change. This caused a fair amount of excitement and news coverage. Perhaps more pressing is identifying so-called deepfakes, as new methods are coming out seemingly on a daily basis. In 2020, we pioneered a study asking the question, can we use today's methods to catch tomorrow's? Surprisingly and encouragingly, we found the answer was yes. Fast forward to today, and thanks to aforementioned advancements in perception and generation, AI-based methods such as Stable Diffusion, Midjourney, and DALL-E are everywhere. Our finding from this paper still holds though. The method is now updated and is actually deployed in a real-world setting in Adobe Stock to help assist users to self-tag and identify synthesized images. But that's not the end of the story. Amazing Gen AI images don't just come out of thin air. They're a reflection of the underlying training data. In ongoing work, we aim to identify the highly influential images that make a synthetic image possible. Such an algorithm could potentially enable recognition and compensation for data contributors. I, along with collaborators, have invented generation algorithms optimized for human perception and algorithms for detecting and analyzing images that fool human perception. These have both led to high academic impacts as well as real-world deployment. I can't wait to continue this work enabling users to better create and better understand their content. Thank you.